It is possible for a function to have two different asymptotes. As x approaches positive infinity, it's possible for your function or your graph to approach one value, while as x approaches negative infinity, the function might approach a different value. So you have rules for finding horizontal asymptotes that you learned in pre-calculus and we reviewed a couple days ago in calculus, but those only work for rational functions, and you won't always have a rational function. You'll have functions that have e to the x terms, or like sine terms, or natural log terms. So to find the horizontal asymptotes for those functions, we're going to need to do some calculus and some limits. So to find horizontal asymptotes, we can find those if we can evaluate the limit as x approaches infinity of f of x, and then also the limit as x approaches negative infinity. So if I ask you to find a horizontal asymptote, you need to do two things. So on this example here, we are asked to find any horizontal asymptotes for the function f of x. So I need to do two things. I'm going to find the limit as x approaches positive infinity, and then the limit as x approaches negative infinity. So let's start off with positive infinity. So limit as x approaches positive infinity of f of x. Well, let me just write out the formula of 4 minus e to the x over 1 minus 6x squared. So I'm going to think about my more dominant terms. Looks like on the top, e to the x is the most dominant because if e is raised to a positive number, then that will get really large really fast. And then in the denominator, negative 6x squared is my most dominant term. So I'm thinking about the limit as x approaches infinity. I'm just going to compare those dominant terms. Negative e to the x over negative 6x squared. And it looks like the numerator is more dominant than the denominator. So I know that this is going to be equal to either positive infinity or negative infinity, and I have to decide which one. So I'm going to think about the sign. Negative e to a big number is positive. Negative 6 times a big number squared. Negative e to a big number is negative. Negative 6 times a big number squared is also negative, and a negative divided by a negative is a positive. So the limit as x approaches infinity of negative e to the x over negative 6x squared is positive infinity. Okay, so I found the limit, and since the limit is infinity, that means there is no horizontal asymptote. But not on both sides of the functions, only on the side where positive infinity is, which is the right side. So on the right side. Okay, now let's check out what's happening on the left side. So I need to find the limit as x approaches negative infinity of 4 minus e to the x over 1 minus 6x squared. So I want to compare my, looks like more dominant terms. So it looks like e to the x and negative 6x squared. But remember, when you have e to a negative e to a negative, that can be a little bit tricky. So let me think about this. Negative e to a negative big number is the same as has a negative exponent. So that means that's the same as negative 1 over e to a positive big number. And let's see. Well, negative 1 divided by a really big number is pretty much 0. So that means this part goes to 0. And now we have a case where we have a constant in the top 4, and then the denominator is growing faster. So because of that 6x squared. So denominator is growing faster. And when the denominator is growing faster, that means our limit is 0. And since the limit is 0, then that indicates that there is a horizontal asymptote at y equals 0. Now, heads up, when you type your answers in Delta Math, they want the equation, so you got to write the y equals 0. And since we're, and it's not on both sides of the function, it's only on the part where x approaches negative infinity, which is the left side. And then we'll do 2 more of these. If you feel like you got it though, go ahead. But let's watch this. Okay, so find all horizontal asymptotes of this function. Notice it's not rational, so I am just going to have to think about signs here. So let's look at the limit. Oh, I need a pen though. The limit as x approaches positive infinity of negative x squared plus x cubed minus x. And so I want to look at the most dominant term. That's really the only one I'm super concerned with is x cubed. So I'm going to think about the limit as x approaches infinity of x cubed. So I think about a big number cubed. That's positive. A big number cubed is a positive big number, which is infinity. So this is infinity, which means there is no horizontal asymptote on the right. Let's find the limit as x approaches negative infinity. Approaches negative infinity of negative x squared plus x cubed minus x. Okay, so again, I'm thinking about the most dominant term. Whoops. Where's my highlighter? Dominant term. So I'm going to be thinking about the limit as x approaches negative infinity of x cubed. So I'm going to be thinking of a negative big number cubed. That's a negative big number. So the limit as x approaches negative infinity of negative x squared plus x cubed minus x is negative infinity, which means there is no horizontal asymptote on the right either. I'm sorry, on the left. And just, for some recall down memory lane, this is a cubic function. It's got a positive coefficient in the front, so cubic functions have this shape. Limit as x approaches positive infinity is infinity. Hey, look. Limit as x approaches negative infinity, negative infinity. Let's do one, I think, with an e. Yeah, the next one. It's a good one. This next one is really good. Okay. Well, this will be our yeah, we can do this last one. All right, so again, I'm going to try to find the limit as x approaches positive infinity of x plus e to the negative 1 over x. I'm going to be careful with e to the negative 1 over x. So let's think about that. 'Cause remember, e can be tricky sometimes, so always examine it first. So I've got e to the negative 1 over x, and this time x is a positive big number. So e to the negative 1 over a big number, well, negative 1 divided by a big number is essentially 0. And e to the 0 is 1. So this part goes to 1. And I really have to think about what is the limit as x approaches infinity of just x. Well, as the x values get larger and larger, the y values approach infinity. So if the limit's infinity, no horizontal asymptote on the right. Now I have to see if there's one on the left side of the function. So let's look at the limit as x approaches negative infinity of x plus e to the negative 1 over x. And again, e to the negative 1 over x can be tricky, so I'm going to examine it for a second. e to the negative 1 over x is the same as, like when x is approaching negative infinity, e to the negative 1 over a negative big number, which is the same as e to the positive 1 over a big number. And 1 over a big number is 0, and e to the 0 is 1. So this part, as x gets larger, that part is going to get closer and closer to 1. And I'm approaching, the x values are approaching negative infinity, so I really just have to think about what's the limit as x approaches negative infinity of x. That's going to equal negative infinity. So there are no horizontal asymptotes on the left either. All right, so good luck with this. If you need any help, let me know. I'll be happy.